Here's a warm-up. A particle moves along the x-axis so that its position at time t is given by this expression. For what values of t is the velocity of the particle 0? When we did the review, we learned about the power rule, and doing this particular derivative is very easy. However, given that in the previous video the most we knew was a slope, I'm going to use a trick. I know that this is going to be a parabola, so I'm going to be using the quadratic formula to do this. Now, when I did the quadratic formula, you notice that it starts with negative b plus or minus square root. Given that I'm only interested in when the velocity is 0, and I know that the velocity is 0 when the particle has the position of the particle has a 0 slope, I only care about the vertex. So I found out what the vertex is. The vertex is at t equals 3 seconds. Now, what kind of a 0 would it be had they asked? Well, this is a parabola that's facing up, which means we're talking about a minimum. Now we're talking about the pendulum problem. A pendulum is hung from a ceiling, as the figure shows, the figure being right here. As the pendulum swings, its distance d from the ceiling from one wall of the room depends on the number of seconds t. Since it was set in motion, assume that the equation d as a function of t. Boom. Also, it's very important, as I talked about the previous video, that you want to know what your variables mean. You want to know what d represents. In this case, d represents, it is the distance in centimeters from one wall of the room, depends on the number of seconds t. Okay, so it's just the distance from the room. Oh, okay, the picture even shows right here. That's what d represents. So, we have an equation right here. Find d when t equals 5. If you don't get 95 for the answer, make sure you use a calculator in radian mode. Alrighty, so that's fun. You just simply plug in t equals 5. That will give you 5 pi over 3, the cosine of 5 pi over 3 multiplied by 30 and then add 80. So I suppose that's easy. Estimate, I have no idea why this exists. It didn't even tell you what the answer is supposed to be. Estimate the instantaneous rate of change of d at t equals 5 by finding the average rates from 5 to 5.1, 5 to 5.01, 5 to 5.001. So you simply do the slopes. So plug in 5.1, see what that equals, and then subtract the value that you got from right there. I see why they want you to do that first. That way, you don't have to keep plugging it in. You can simply just find the answer and then use it for each one of these 3. So the only calculations you really have to do is find out what you get in this equation. Let me go ahead and use a pen now because it's getting too confusing. This equation, all you really have to do is plug in 5.1, 5.01, 5.001, put in your back pocket, and then use them in these slope equations right there. Alrighty, so when you do this, when you do it at 5.01, as I said before, this is not going to be your most accurate answer. You're going to get this. And then you get closer with an order of 10 times closer, get this answer. And by the way, when you have a distance equation and you find the slope, that becomes a speed, as indicated by centimeters per second. And then the closest possible way, which is right here, 27.199 centimeters per second. Okay, so we did what it asked, so let's move on. Why can't the actual instantaneous rate of change of d with respect to t be calculated using the method in part B? What I think they mean by that is, how come you have to get infinitely close to it, and we talked about the derivative being a limit, instead of actually being right on top of it? For one, if you have a point, and then let me go ahead and let's say that's a point, and you have a point that's right on top of it, you don't have a sense of direction because you need 2 points to create a line. And another problem will be what's outlined right here. If you were actually trying to do the slope, you would just simply get 0 divided by 0. But actually that's not the main issue, right? The main issue is this. If you're trying to find a rate of change, you have to find the slope of a tangent line, and having a point exactly on top of a point will not give you a line. So that's the main reason, but you can certainly use this reason as well. Alrighty, let's move on. Estimate the instantaneous rate of change of d with respect to t with respect to t at t equals 1.5 at the time is the pendulum approaching the wall or moving away from the wall. Okay, so since d represents the distance from the wall, that implies that a positive slope would imply it's going away. Come on. A negative slope would imply going closer, and that's because when you have a positive slope, it means that the number is going to get larger and larger and larger. The distance from the wall gets larger, larger and larger, which means that it's going away. With a negative slope, it means that the distance is getting smaller. I hope that makes sense. So let's find out what that will become. So we're going to go ahead and use a method like we did before, where we try to approximate as close as possible. And we end up getting a negative slope. And like I mentioned earlier, a negative slope means that we are going towards the wall. Now, the reason why I'm asking you guys to do this is mainly because the book asks you to do it, right? Because we already know that the 1.5 to 1.5001 is going to be the most accurate anyways. So why even bother with 1.501 and 1.51? Because you have to earn your stripes, right? That's why. Just, when you have to go through the trouble of using 1.51, you notice that what the differences are going to be. In this case, the difference was very, very small. But when we used for the problem from yesterday, the 0.1 to 0.01 was a vast difference. It was pretty big. That's why. All right, I'm going to go ahead and let in the kids. They're waiting in front of the door. And that's the end of this video.